being here. My name is Matteo, and today I'm going to speak about components, microservices, APIs, and front-end. So, who am I? I am a software engineer. I'm based in London, but I'm Italian, and I work for a company called OpenTable. I write code, so I'm a software engineer. I like conferences, and I like open source, and I've been writing code for many years now. So first, before speaking about components and front-end, I want to tell you about the place I work with, because that's where everything started. So OpenTable is a company that is about restaurant reservations. We provide software for restaurants, but also I wanted to show you some numbers to understand the volumes of traffic we have and the kind of problems we have. So we have more than 32 restaurants worldwide. We have more than something like around 500,000 reviews per month that comes from our customers, from our consumers. We have more than 16 million reservations every month. And we are, more technically speaking, in America, Europe, and Asia. We have our data centers a little bit everywhere. We have software written in, I think, any kind of language. And everything starts a couple of years ago, when basically as a company that have been on the market for more than 15 years and have been seeing hundreds of engineers working in different continents, had that monolith. So many years ago, we decided to break it, so we add a single application and single code base for a big consumer website deployed in multiple parts of the world. We add the same code base we used also for internal services that were used by mobile, because we have mobile apps for any device. And we also were using the same code base for external APIs, so for something that we needed for integrating with partners. So obviously, the situation was not ideal. We had deployments every month, then we switched to every 2 weeks. I've seen worse, but it was still not great, not very resilient, so we had to queue any change to be deployed in 2 weeks. And when something was bad and something was not working, the only option was to roll back, because we were not very able to move this big monolith and application that needed a couple of hours to be deployed. But still was good, because we had one single language for everything, and that was good because we could share the best practices for, in our case, C# and Windows in general, and also was good because we had a dedicated team for infrastructure that was very specifically focused on Windows, and also, as a consequence, also we had a specific team for testing that were very focused on testing application of that kind. So, obviously, a couple of years later, we went to the SOA route. Well, the first thing we wanted to do was to split our internal logic to little internal services. So we started breaking pieces of functionalities, and what we did was to introduce something that was a little bit on the code, a little bit on the culture. So something is about rewriting pieces of legacy code, but something also is about reorganizing teams, having small 2 to 4 people in our case, very focused teams working on very specific pieces of functionality, and they were able to break critical parts of the system and build little services. After a couple of years, obviously, we've been good and improving to make these services, as we discussed today, very well tested, discoverable, create consistency about how we do things like logging, and as a result, a couple of years later, we were quite impressed about the progress. A couple of new things we've seen was, a little props, was obviously the system was made more robust, more scalable. We were able to scale better, because obviously we have different options. Depending on the service, we could scale horizontally or vertically. And also, obviously, we were more robust. When something was bad, obviously, everything else was good. And also diversity on tech stack, which is actually something interesting, because I am quite opinionated about the fact that I love it. Somebody says that is a bad thing, but in our situation, that was the first time we had the chance to experiment with new languages, because many teams were very convinced about the fact that a very little service was better to be rebuilt with a new language, with a new technology, and that worked very well. So given that we were very enthusiastic, we started to think about how to break the web. So when we broke the backend, we've seen a lot of benefits. It required a lot of effort, but at the end we had this big legacy website still, and we wanted to do something about that. So it happened that when we did this, a new team just built a new availability service. So they were very expert about search, and they were starting to experiment with new search algorithms, because in our website we have a search, and users need to see these results. So it happened that when this team started working on integrating new features on the front end, they started experimenting with something we started to call microsites. So microsites are what? Microsite in our world is one page, or maybe 2 or 3, but a very small contained, speaking about logic, piece of software that is about the front end. And it is obviously built in any kind of language. It can be Node.js or .NET. But the main goal is to basically take what we learned from the back end and bring it to the front end. So if we have a very small set of web pages that can be deployed in a couple of minutes, and obviously can be tested more effectively, because we need to test something very small. And we also are taking the opportunity to rebuild something from the legacy. We can actually focus on building something very small and have a very small team dedicated to just that. And so, if you want, this is a little bit unusual, because I've seen on many big corporations to have a single front-end team that actually deals with all the microservices or services that are on the SOA world on the back. But actually, we wanted to experiment, if you want, in a more kind of vertical way instead of on a horizontal way. So the idea was, why not the same team that handles the logic about the search can build also the search part on the website? So what we did at the beginning was to do a little hack on the front-end routing in order to say, if it is about search, go to the microsite. If it is not, go to the main website. And after we've been experimented a little bit with that, we tried to think about how this could scale. So microsite could be a way to break websites. So can we have a website, a microsite for the home page, a microsite for search, a microsite for anything else? We wanted to see if it worked. And we tried, and actually it worked very well. So first things were, we realized that small teams were now handling very small pieces of front-end and back-end. And that worked very well, because they had also very specific business objectives. Like the search team wanted to improve search, wanted to improve conversions, wanted to improve the quality of the search results. And if they had the total control from the backend to the front end, that was very good for them, because they were able to do daily releases and to be unblocked. Then they could do more focus on effective testing, obviously about automated testing, but also end-to-end testing and even A/B testing, because they were totally able to control the same piece of functionality. Obviously, the system were more robust if search was down or everything was up, and vice versa. Also, diversity. It happened that we were quite in love with Node.js for the front end, but we were not so much in love with Node.js for the back end. So we were kind of super popular on the front end, and a lot of teams started to adopting it, because now they could focus on having a small piece of Node.js applications that were focused just on the front end for a little microsite. But it wasn't that easy. So what we realized is microsite couldn't work very well on a scale level, because static resources duplication. Obviously, if search had its little logo on top, they wanted to be totally decoupled from the legacy software, so they wanted to host the logo in a new place. So the logo was duplicated. The user was going to the website, was navigating. We wanted to feel to make the user feel that he was still on a unique website, but in reality, the user were navigating to something that were duplicated, so it wasn't very performant. Obviously, a lot of duplication on the JavaScript, the CSS, and all the markup, because they wanted to be encapsulated and totally unblocked. And we had to deal with inconsistencies. Obviously, if I had a website with a little link on the footer to change, before I could do just a change in a piece of software and that was live as soon as I was deploying it. Now, I had to coordinate this change with two teams. So one team of that microsite and another team for the main website. And obviously, in a situation of a lot of microsite, I had to coordinate this thing with a lot of little teams. That was crazy. We had to deal with inconsistencies. Obviously, performance, as I mentioned, we have something like every microsite wants jQuery, wants these kind of little libraries. Everybody was duplicating it. The result was that every time a user was clicking to a different page, it couldn't download 200 or 300 kilobytes of stuff duplicated. It was very unperformant. So to solve this, we created a new API. So we called Site Resource Service, a little service that were needed to make the microsite approach work. So the idea was to create a little REST interface that could share the common parts of the website in a form of HTML snippets. So the idea was if all the shared parts, such as the header, the footer, the adverts, and maybe the JavaScript and CSS resources are shared and served via a specific API, then all the microsites can consume that API every time they render a page so that we have consistency. Everybody is rendering something, and we can, as soon as we deploy this API, introduce changes. So we created an API. We tried. It was really an experiment. We didn't know what to expect. We created a REST interface, HTML as an output because we had to put this HTML in Node.js applications, in C# microsites. We needed something like a unified standard. And rendered HTML at that moment was the easiest kind of win. Using headers such as the accept language for languages and different parameters to get the different variants, and then obviously the ability of hosting some kind of server-side logic. So if the header was a piece of functionality that needed to consume a service such as user API internally to get the information about the user and render some information on the top, the idea was this service could do it for you and could actually have maybe expensive or sophisticated mechanisms, caching mechanisms, etc., to give you a very quick response, so you as Microsite developer could just include the response and stop caring about everything related to the header. If you wanted the header, just make a request and push the HTML. Obviously, ability to house static resources. So if all the static resources, including in the markup, retrieved by the API was hosted in a single place, that was very performant for a browser perspective, because the browser could cache all the resources when people were clicking in different places and were navigating a big website. And obviously, as I mentioned, we created components for specific UI components, but also for something like the core JavaScript libraries and the core CSS, so that everybody, including that set of 5 or 6 components, could have a microsite that was ready, a kind of a scaffolding application. I could start developing just its own functionality. So today, after 1-2 years of experimentation, we decided to go to that route, and it worked. So today, if you go to the OpenTable website, you can actually see a simple page. You can't find out what is happening, but on the back end, actually a lot of components are coming from a unique service. And we have something like 20 microsites to power up all the website functionalities. So the idea is that there are different teams. Sometimes they are located in different geographic zones. So maybe there is a team that here is connected to product, and they have very clear objective in Europe because they want to improve a specific part of the website. They can do it without absolutely being blocked by our colleagues in the US that have a different time zone, and they have obviously not a very easy way to communicate. So obviously we thought about other solutions. There are other ways to solve these kind of problems. For example, client-side rendering. If you do IX requests from the front end to get shared components, you can do the same thing, but obviously you don't have the benefit of a search engine optimization that we needed for things like the header and the footer. What about iframes? Pretty much the same, plus iframe doesn't allow pieces of UI to communicate through them in a kind of an easy way and in a cross-browser environment. Server-side includes, so something like Nginx or other proxies or other vendors provide something like proxy service or things that can compose front-end pieces to pretty much do the same thing. The problem for us was that was something like some kind of entities that are trying to put some magic in my system. Instead, here I had very clear contracts. I had a REST API that were serving components with a name, with parameters, and the contract was that if you were a consumer, so a microsite, you could consume components in a specific way. So I had flexibility, but also very clear contracts. Another theory is, what about asset compilation during build time of microsites? The problem was we wanted to scale. We wanted to arrive, like today, to 20 microsites. If we add the problem of consistency and then we add something like that, then we needed to rebuild 20 applications and redeploy them every time we wanted a change to be visible everywhere. But, so, did it work? So, yes. Consistency, obviously we add consistency. Everybody had to just put that, to make a request to put there. Every time we wanted to make a change in a shared part of the website, that was there. Coordination was solved because now a single team were handling the shared part of the website and were deploying this API every time they needed to do the changes, and every microsite were unblocked because they were focusing on their kind of problems. Front-end was solved because now everybody was sharing the same code when the browser were analyzing the code, so that was optimally done on the browser perspective. And obviously the browser were able to cache all the static resources. And it was even easy to spin up new microsites because obviously as soon as we had all the main components created, we started creating new microsites for testing new functionalities on the website, or even to do very small experiments for little variants to components and to try to improve our business. But obviously not a free ride again. We add a new R dependency. So one of the coolest things about the microsites were if another microsite is down, every other microsite is up. So I have a website that maybe is down or is slow, but if now SRS was down, everybody was down. If SRS was slow, everybody was slow. So we had to work a lot to make SRS reliable and quick, and we had to deal with also load testing, and so we had to prove that that could scale in depending on our business requirements. I'm speaking about millions of requests per hour, keeping, just because someone mentioned some numbers before, the response under 10 milliseconds in our case. Again, another problem was that people were so excited about that they started saying, I'm creating this, but that's required also for this other microsite. Can we create a component for that? And say, yeah, make a pull request, we can create a new component, but slow down, because obviously we don't want to create a new monolith about shared components. So after 1.5 years of production and success, I think, personally, we decided to go to the next thing, which is called open components. So if microsites are something like microservices for a website, the idea was to elevate the components themselves as a service themselves. So instead of having something like a site resource service or a single API, we wanted to find a new way to empower people to create components and to view them at least in an abstract way as a service itself, so that they could handle a component and its resources and its obviously its capacity and its response time, etc., in a kind of encapsulated way. So we wanted to enable people to create new components. We wanted to see this in this perspective. We decided to be a little bit more opinionated about how components could be. And we decided to start considering them as data in order to have something like a service, something like a registry, where all the components could be registered and discoverable, but actually that could be used by everybody to create new components for the front end. We wanted also to allow microsites to have more granular control. So we decided to start semantic versioning components and to make them immutable, so that people could create new components, could use the API to publish them to the registry in order to make them discoverable in a semantic way. And then we wanted to enable microsites to consume maybe a specific patch or maybe the latest version or just the latest minor version of a component. And obviously, we wanted also to optimize client-side rendering. That's why we decided to develop a little technology and a little set of clients to avoid doing the rendering on the server, but actually to serve the components in a non-rendered way. So that's for performance perspectives and also for reducing the response and the communications that was required. And also we wanted to serve as a framework for A/B testing because we are a company that is experimenting a lot. And previously we had multiple strategies to do A/B testing that pretty much were something like, I have some code, I have a platform, or I have a third-party tool to put some code to test it. I have some analytics platform that measures the result, and then I want to see what happened. In this way, we actually could create components in 5 minutes, could publish them, they could be there in production, and then the test would be just serve this component or serve this other component. And that would be a better way because the code for the component itself could be versioned, could be on GitHub, could be manageable via pull requests, and could be deployable in a continuous integration environment after running tests, etc., etc. So I'm going to skip about the architecture because it's almost time, but just to mention how it works. We basically created something like that. So on the client side, when you want to use a component, if you have a registry and you use a client that we developed, you can include a component in a way like that. And that works on the client side, but also there is a piece of that translates this for doing server-side rendering. So the idea is now the service is able to postpone the rendering, is very intelligent, and people is very unblocked for experimenting, creating new stuff. If you want, it's something like a component as a service. So, conclusions. SOA is not just about code. A couple of years ago, we started to experiment with SOA. We wanted to have our system broken into very small services and microservices. But what we realized is that the complexity lies not within the people, the code, but also within the people. As soon as we start evolving your code, very often the relationships between engineers and actually the way they work evolves as well. So in our case, what we found out on the front end was, in our case, one of the biggest problems was to work with people geographically located in different places. And actually, on the SOA world, when you have a lot of dependencies, reduce dependencies and have very clear contracts, even on the front end, I think was a very good investment. Then we need love. So what I mean is going to the SOA, even on the back end at the beginning, wasn't easy. It was a result of years of experimentations and failures. We learned how to scale systems. We learned how to centralize logging. We learned how to be more fault tolerant. And after that, we were able to bring this experience to the front end. Because we already knew this kind of problems, we were able to tackle them in a very structured way. So when we decided to put up an API in the front end, and we decided to tell everybody that they were rendering an HTML, they were doing a request to a service, that is kind of crazy because it's very, very crazy. We actually built a service that were able to respond very quickly. And if we wouldn't have a very stable service and very robust and very fault tolerant, that couldn't work in the first place. Last thing is open components, which is our experiment, is open sourced. So it's been in production now for a couple of months, but we are still evolving it because we are trying to make it more scalable and more contained. So we are experimenting with containers in order to scale even more. But it's already in production as it's handling millions of requests per hour with 6 and 7 nines of availability. So it is working very well for our, obviously, needs. And thank you.
We have time for a few questions. Thank you very much for this talk.
Okay.
Yeah, one question here.
I wanted to know more about your team and its effect. The microservice had the effect on your team. How big is your team? What challenges communication-wise did you guys have, and how did you overcome them?
So now I don't perfectly know. I think we are a couple of hundreds now of engineers. We were something like the half last year. So we are something. Things are changing, but the thing is, for us, I think the most one of the most problematic things, if you want, was to optimize communications between different geographic locations. So we have a small engineering team in India, for example. We have 50 engineers in London, then we have engineers in San Francisco, and then there are contractors a little bit everywhere. When you have teams that work on the same projects, you can make communication and remote working smooth, but the reality is that if you want to make these people work very, very well together, and in the SOA world it is required because everybody depends on anybody, you need to do your best to optimize this communication and these workflows. So when we were working on a single code base at the beginning, and we were releasing that every 2 weeks, we had a very nice way to do it. We had pull requests, we had different branches, but the problem is that if a person needs a code review from a person that is in San Francisco, he can't wait until 6 o'clock in London, but then he needs to wait to approve it, and maybe he wants to think about that, so he's going to go out for the next day. So the idea is if you can break everything into smaller pieces, maybe it works for the front end. So for us, the biggest bet was to validate the idea that if that works for the back end and for the microservices world, maybe it may work for the front end as well. And we are still experimenting, so I don't know the answer yet, but for us it's working very well. Maybe it may work for someone else as well. Hopefully I answered.
Another question? Okay, thank you very much.
Thank you.